just going to do a quick run through on how to use the EEGLearn package to clean the TDBrain dataset. Just to be clear, this package is entirely focused on the TDBrain dataset, but uh, theoretically you could make it work with any EEG recording as long as it follows the shapes that I expected. So basically, if you start off with a CSV where the columns are channels and the rows are is the time steps, can make it work. But depending on the number of channels and stuff, you may run into some problems. But that should be fixable because I've basically hard coded that everything's 26 channels based on this data set. But changing that should not be a huge lift, but you would have to do a bit of work. So I haven't done that yet. Anyway, so um, first step first, I'm assuming you know how to git clone a repo, so you just do git clone, and I've already done that, and I've already opened the repo up, so I have it here. I'm just gonna clear these things. Okay, so I've opened the repo. I'm just in here, and the next thing you need to do is to get access to the data, and to do that, you have to follow the data use. So you go to TDBrain data thing, and you go here, resources, and then you access the data set. You do the whole logging process, you get the data set, etc. So I already have a data set, and I have a sample of that already. So I'm just gonna put it where it needs to be. So once you have access, you get the data, you get the data set, and you get this labels file, which has all the information about like each participant, and you get this TDBrain data set, which is like a big bunch of CSV files. And to begin everything, you need to put the data in the position. So this is each column is a channel, and each row is and is n time steps long. So to get it to work properly, you have to make sure this data set file and so I'm just going to delete something because this is from previous run. And this thing are in the right place, right? So in this data folder, I have a picture here that shows you how the structure should be like. Yeah. So the data folder should once you clone the repo, this data folder is empty. You just copy the TDBrain. You get the file exactly as you get it. You copy the TDBrain file directly into the data folder, and then you put this participants v2 file that you also get again also in the data folder for the feature extraction. But for the pre-processing, you don't need this TDBrain v2. This is only when you do feature extraction, just to get some additional information that you need. So feature extraction meaning when you want to generate the energy band features. Okay, so once you have that downloaded and you have everything ready, all you have to do is just do so I'm gonna go back here. You're in here. This is the root folder. First thing you do is just to setup conda environment.sh, and this will set up everything you need in the conda environment. But I've already set it up, so it's just going to. Well, no, apparently I haven't because I think I removed it already. But we removed it. No, existing content environment. So it's already existed, so that's fine. But otherwise, it'll find all the packages you need. It'll install everything. Should be hunky dory. It handles it if you're in Mac or Linux or Windows, so it should be okay. You see, I have two different YAML files here for environment files. So once that's ready, you conda activate EEGLearn. That's the default name for the environment. So I'm already in there. And once you're there, you can just to get the clean data. So I've removed everything here. You just do clean.sh, and this figures out your operating system activates the environment if it doesn't already, and then just processes persistence files. So here, just to show you, I'm processing two random subjects because I've defined it to be sample two here just to make for brevity. But if you make it 0, it'll clean every single file that's inside this TDBrain dataset. Okay, so all the parameters you want to adjust can be adjusted here. For example, the length of the epoch you want, and if you don't want epochs, you can just take this epoch length parameter out entirely, and the default is to not do any epoching. So it should be fine. Yeah, and then you can choose whether you want to use the eyes closed, the eyes open. So this is the thing, like with um, using other data sets, as long as everything is sort of structured in this way. So even if you don't have an eyes open, eyes closed condition, if it's like structured and named like this, the file structure is like this, because this package relies heavily on following the folder structure of the TDBrain dataset, the way it's given, which contains a lot of the information that you need to do any processing and stuff like this. So if it's in this format, I think it's possible, but I have not tested that. Anyways, so you can define everything you want here. And plots equals true. I'm just putting it true here to show you what you get. If you said plots equal to true, you get these plots of before and after of before the processing and after processing, and then after before and after ICA and the prep cleaning steps. So if you are interested in that, you can put that. Of course, if you are cleaning all 1,200-ish files, generating these plots is quite useless and it's quite slow. So you can decide what you want to do there. Yeah, it is everything in parallel. So even if you're doing just two files, there's a small startup cost because you're setting up the two processes. But if you're doing 1,000 of these files, that cost is negligible and the speed up you get is valuable. So everything is handled in parallel. Yeah, so now you have everything cleaned. So basic, the files are clean, and I'm just going to show you what you get when you do this cleaning process. So I have this little TDBrain notebook set up. Just importing. So I'm just importing one of these pre-processing files, right? Okay, so I'm just going to do, maybe the path has changed because it's a randomly sampled something. So I'm just going to copy this, copy path. Yes. Or something. Yeah. So run that, and then this just shows you all the things you have. So because what you get is a pre-processing object, and the pre-processing object is defined here, preprocessing.py, and you get this pre-processing class, and I have all the information here. You just have to read the readme. Read the doc strings, and tell you exactly what's where. And the comments are also very quite verbose, just for clarity. Yeah, and all the steps you can find here. So here it just tells you what options you have. So if you take, and each of these each end product is an MNE object. So all of the things you're familiar with MNE is in theory and in practice, at least my experience, available for you to use on this thing, both on the epochs as well as the raw object. Okay, so these are all fine. Um, yeah, so you can do all the M&E stuff you want, and yeah, that's basically for the pre-processing. Everything's handled very automatically on the back end. And if you want to really understand step by step what's happening, I recommend you go to the code, look at the doc strings of each of the files, and it's I've written everything out very clearly there, so you can see like the doc strings are quite informative here, for example. And even in here, everything's quite, I've written everything out quite lengthy. You can, yeah, check everything. Okay, so that's that. And also, if you want to generate the energy band features, um, you could, so one way to do it is like you have this clean path, you have the labels file, you define these two things, and then you just literally say, you make an energy object, you import energy, you at the clean path, and then you say what you want. Do you want to do the full time series? No, I want to work with epochs because I have epochs in my clean. I mean, I can also do epochs and full time series, but here, because I did the cleaning for using epochs, I'm going to use this. Do I want the energy plots? Yes, I want energy plots. Um, do I want the verbose output of the spectrum decomposition paths? Yes. And then I'm picking just the EEG channels from all the channels, because here there are 30 channels, but only 26 are EEG. Then I want to include bad PSD. Like this is basically saying like, because some channels are bad even after interpolation, and you can figure out why that is in your own time. But essentially, it just does that and then gives you this energy data set, right? And then once you run the energy data set, run energy parallel, what you get is you get this. Um, run energy parallel, and it's going to do it, create the energy files, oops, right? And then if you do dataset, the dataset, this is energy, so you do dataset 0. This is a big, these are two tensors in this object. So the first is so if you look at the first object here, this is the raw data. This is the matrix. Okay, so 12 epochs, 26 channels, 5 bands for each channel. The band, so for each epoch, for each channel, the energy band, right? And then if you look at the next object, oh boy, God, this is super. Data set 1. This is, sorry, this is 0, 1. These are the channels that are included, okay? And then if you do the data set 0, 2, cursor trying to be a bit too smart here. And then it just tells you, the subject ID, etc. I think there's more information maybe here or not. Yeah, so it gives you subject ID, the condition, and its label. So I think if I do, yeah. So for each subject, it gives you the raw data. Just gives you the numbers. For each channel, each band, what is the energy, and then the channels included, the subject ID, the condition of the subject, and what the label of the subject is. So this is very helpful, right? So basically, what you have here is you have transformed a raw time series. You've taken a raw time series, you've cleaned it for noise and artifacts and all those beautiful things, and then in one simple line, in 2 lines of code, you've got energy. Made the energy object. You told it the things you want to use, and then you just do run energy parallel. You process all of them, and then now you have this cute, nice nice object. So the data set is now in energy feature form, right? So basically what you have is you have the n epochs by n channels by n energy bands matrix for each person, for one person. You have the number of channels, EEG channels, and you have the ID of the person. You have which condition was his eyes closed or eyes open, and you have the label, psychiatric label of this person, right? And with that information, you can just start using it to do whatever you want with these features, right? I mean, and if you don't care about these labels, but the thing is, you can use this ID to go into the participant file, participant information file. So let's say you want to do something with the 5-factor personality thing. You can use that ID. You can use the participant ID, go in here and get the row of their 5-factor thing, and then do some other machine learning stuff on it or analysis on it, or whatever you want to do. So yeah, that's the essential structure, right? So first step, clean, then the energy features, and you're good to go. The energy generation won't work unless you've cleaned it, so make sure you clean it first. Yeah, that's how you use it. Hopefully it's useful. At least the cleaning step should be useful for a lot of people who want to use this package because it's just one line of code. And yeah, hope you guys hope it's useful to everybody. And yeah, thank you.